Let's do this example. X prime equal to A times X. A is this matrix. As usual, we find the eigenvalues and corresponding eigenvectors. A minus lambda I. 6 minus lambda minus 17. 8 minus 6 minus lambda. So lambda minus 6, lambda plus 6, 8 times 17. 136, lambda square 36, 136, so lambda square 100. So this one equals 0, lambda square equal to minus 100 or minus 10 square, or minus is I square. So we know that lambda 1, 2 is plus minus 10I. So we're pure imaginary eigenvalues. And in this case, when we have complex eigenvalues, we just need to pick one. So consider lambda equal to 10I. The eigenvectors A minus lambda I V equal to 0. A, this matrix, minus lambda I 10I. A is this matrix. Now for the eigenvalues, complex eigenvalues, this will give two dependent rows, so you can just keep one row. So this row gives us, say V is AB. This one is 0, 0, so 8 times A minus 6 plus 10I times B, 0, or divided by 2, 4A, 3, 5I, B, 0. So we can choose A to be 3 plus 5I, and choose B to be 4. So we see that 4 times this minus this times 4 equals 0. So we have eigenvectors V 3, 5I, 4. 3, 5I, 4. Now we have the eigenfunction. Let's call it F T V E lambda T. 3 plus 5I E minus 10, positive, we choose 10I, 10I T. So we use the Euler formula. We write this down. Psi, maybe I should recall that, E I theta, cosine theta, I sine theta. So this is the Euler formula. Theta in our case we use to be 10t. This one times cosine 10t, I sine 10t. This one is 3 cosine 10t plus 5I square sine 10t. So I put on the real part, and imaginary we have 3i sine t, sine 10t, 5i cosine 10t. The other one we have 4 cosine 10t plus I 4 sine 10t. So let's group that I out there. First of all, minus I square minus 1, so minus 5 sine of 10t. Second of all, this I can be pulled out here. I times this. So now I can separate real part and imaginary part. The real part gives us the first solution we have. What's the name we should use? Okay, use x1 t, real part of ft, f1, ft. This might confuse with the axis, so I don't use x1. Just keep real of ft equal to this real part. The imaginary part of ft this is the imaginary part of ft. So the general solution is a scalar times the real part plus another scalar, or maybe the same scalar, times the imaginary part. xt c1 times this one plus c2 times the other one. C1 times this, C2 times this. In our case, here, imaginary. Eigenvalues. Then it gives us the ellipse. So let's sketch some of them. Qualitatively, it should look like this. So, for example, let's see which direction is go. Let's just pick M. The point is 1, 0. At 1, 0. Get the matrix. 6, 8. Right. So this matrix times 1, 0. You have the first column 6, 8. So it's pointing up there. Yeah. So it should go like this.